Welcome to Contemporary Math, Section 2C, Notes on Problem Solving and Guidelines and Hints. So in this lesson, we're just going to go over a pretty good overview on how to problem solve and what it means to problem solve. So the solution to a word problem may be short and simple or time-consuming and difficult. Problem solving can be both very frustrating and very rewarding. A lot of students forget that. Once you get the correct answer from an actual real world problem, you should have a sense of pride in being able to get that answer, not just being frustrated along the way. The ability to be a good problem solver is an asset in the real world, although some of the word problems that we do may not be of practical importance, though hopefully some will be. What is most important is that you develop a good approach for solving problems. Keep in mind that a good problem-solving skills are largely the result of experience. Yeah, just like the critical thinking section that was covered, I think that was just the last lesson that I had uploaded. So practice, practice, practice. I was going to say, in order to become a good problem solver, you have to practice problem solving. Just like if you want to be good at anything, you have to practice those skills. So hang in there. You will get better at it if you are willing to put in the time and the effort. The following approach is what we will use in this course, this 3-step method. So go ahead and pause it, read these 3 steps, and we'll come back and start looking at some common errors and then some examples. So some common errors happen to be misreading the problem. Normally when I teach this class in person, I tell my students the first 2 steps to problem solving are read the problem for step 1, and step 2, read the problem. Make sure you've read everything correctly. Another common error is when you copy something wrong, or using an incorrect setup, or making a computational error. That's a little error in math, like you forgot the negative sign, or you added instead of subtracted, whatever it may be. Just a small computational error, or making a basic error in reasoning. So as we look at the examples on the next couple slides, or I guess the next slide, we need to be sure that we are not making any of these errors as we go along. And there are some hints down here. There may be more than one answer to a particular problem. And this is big in engineering. There might be multiple solutions proposed, and then there are discussions that are had to figure out which solution may be the best solution. Consider simpler/similar problems, or drawing a picture. Drawing a picture is big in math. Math is based on a lot of theory, and if you can put a picture to it, generally there can be a better understanding. There may be more than one strategy to solving the problem, so keep that in mind as we go on. And the 4th hint here, do not spin your wheels. If you've been working on the same problem for a half hour, time to close the book, shut down the video, close my math lab, whatever it is you're working on, walk away, clear your head, come back and think of it a little bit later. On this slide, we will look at multiple examples to help you solidify this problem-solving technique. So what I'm going to do is I'm just going to prompt you right now to read this particular example at the top. And using the 3-step process from the other slide, go ahead and see if you can solve this problem. Again, the 3 steps are to carefully read the problem for understanding and strategize. More specifically, what facts do you know? What are you being asked to find? Is there a formula that applies to the problem? Will a picture help? Just start writing something down. The second step is solve the problem using the strategy you came up with. Adjust as needed. And the third step is make sure that you've answered the question and that your answer makes sense, aka check your answer. So go ahead and pause the video, try solving this example. I'll come back in a few seconds with a solution. In this scenario, you can see that Chad worked the first shift at the box office and he sold this many dollars worth of tickets. So you know children's tickets cost $10 and adult tickets cost $20, but he didn't keep careful count, as Chad does. How many tickets of each type did he sell? Well, one situation that could happen is if 13 children's tickets were sold. So let me take a second to write that down. So if we think about that just for a second here, 13 children's tickets times $10 per ticket, 13 times 10 is $130. So if 13 children's tickets were sold, that would also mean that 0 adult tickets were sold. But this is not the only answer. In fact, this answer doesn't make any sense. 13 children and 0 adults, like in the real world, we just call that chaos. So maybe something that would be more realistic would be 5 children's tickets and 4 adult tickets. So it's possible there could be 2 sets of married folk, 4 adults, and one set has 3 children and the other set has 2. That would make a lot more sense, but does this answer fit with all of our numbers? Well, 5 children would cost $50, and 4 adults would be 4 times 20 would be $80. Yeah, 50 plus 80 is $130. Yeah, that works. So this I feel like would be a much more realistic answer, but not, again, not the only answer. There are many answers, such as these. All of these other situations here absolutely fit with the numbers amounts. So if you had 9 children times $10 per ticket per child, 9 times 10 is $90, and 2 adults for $20, that's $40. So 90 and 40 is still $130. So there are all these situations that could happen. It's good to know that any of these could happen. I really feel like, again, that this is like probably the most realistic, or maybe even these two if you want to consider like a daycare taking a field trip, or a school, elementary school class taking a field trip, things like that. These other ones are kind of awkward in the real world, but I guess they could happen as well. Taking a look at the next example. When running a race, what place are you in if you take over the person who was in second place? So I think drawing a picture is going to help with this one. So here's second place, and here's first place, and here is the ribbon to finish the race. All right. So you take over the person who is in second place. Here you are. And you pass the person in second place. What place are you in? Well, if you move in front of the person in second place, this person is no longer second, they are in third place, and you will be in second place. So I think drawing a picture here works very, very well. So for example here, the problem-solving process, I carefully read the problem here, and I was starting to understand and strategize. I wanted to think about how I could do this. One of the things with strategizing is asking, will a picture help? That was the first thing I wanted to do, was draw a picture. Then I used the facts that I saw here to strategize and come up with a strategy that I could use. Then the third step, make sure I've answered the question. The question was asking, what place are you in? So I circled second place. We would be in second place then. In this third example down here, a farmer has 17 sheep and all but 9 die. How many are left? Step 1, carefully read the problem for understanding and strategize. So this says 17 sheep, all but 9 die. And that's confusing. So maybe I should draw another picture here. So here goes my picture of my 17 sheep. I hope you enjoy all of the detail I've put there. So there are 17 sheep here, all but 9 die. That's an awfully confusing phrase. Maybe we should say 9 live. So if that's the case, all but 9 of them die. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 didn't die. That means all of these died. How many are left? Well, 9. There are 9 of them. We drew another picture. We had to carefully read. Step 1, read. Step 2, read again. And just try to understand what was there. But we were able to get an answer, and yes, this answer does in fact answer the question. Next example. You are in a cabin and it is pitch black. Not one shred of light. You have a match, though. Which do you light first? The newspaper, the lamp, the candle, or the fire? And this question is very, very misleading because the answer is not in the list of things that was given to light first: the newspaper, the lamp, the candle, or the fire. You can't light any of those things until you have lit the match. The match has to be lit before you can light anything else. So this particular example exploits, common error number 5 in the last slide, which was making a basic error in reasoning. So if you first read this and you say, oh yeah, well, the candle, because maybe the candle will burn the longest and you can light the newspaper from the candle to maybe light the fire and, do the whole strategy thing for what you would light first and what you would light last. You can't light anything without the match. So we had to read it very carefully. What facts do you know? You know you have to light the match before you can light anything else. Is there a formula that applies to the problem? No. What are you being asked to find? What do you light first? We have an answer for that. Second, solve the problem using the strategy after you critically think about this situation. Last, make sure the answer makes sense. Check your work. Done. All right, the next example. Stan placed exactly in the middle among all runners in a race. All right, so let's get Stan down here. I'm going to have to draw myself a picture here. There's Stan. Dan was slower than Stan, so I'm going to put Dan over here, slower. I'm going to mark it so I don't forget. Slower to the left. And 10th place. Oh, so Dan was in 10th place. Oh, we also know Stan was in the middle. So let's get all this down in a picture. There we go. And Van was in 16th place. And the question is, how many runners were in the race? Well, I'm wondering, is there even a way to know how many runners were in the race? And in this case, it is absolutely possible to tell how many runners were in the race. The first thing that you need to do is first consider, we know Van was in 16th place, and we know Stan was in the middle. So that limits how far forward Stan could be. Like, we can't say Stan would be second place, because then Stan wouldn't be in the middle of 16 people. But we know Stan has to be 9th place or higher, right? 9th place or 8th place or 7th place or 6th place, and so on and so on. Another fact that you need to remember is this. If there are an even number of runners, then there have to be 2 runners in the middle, or I guess more technically, no runners in the middle. But if there are an odd number of runners, then there only has to be 1 runner in the middle. So if Stan is in the middle and we make Stan 8th place, 8th would be exactly in the middle. That means there would be 7 people in front of him and 7 people behind him. So there'd be 7 and 1 is 8 and 7 more is 15. That means Van could not have even been part of this race. But if we make Stan 9th place, that means there would have to be 8 people in front of him and 8 people behind him, which would allow for Van to be in a place, 16th place. But if we count 8 people past 9th place, there would be 17 total people in the race. This is a mind bender. So sit down, think about it. If you don't quite understand my explanation, think about it and see if it makes sense on your own. The last example here, we have Emily. Emily bought a painting for $750 and sold it for $900. Then she bought it back for $1,150 and sold it again for $1,500. How much did Emily gain or lose on these transactions? All right, so if you pay for something, that is money going out. So that'll be a negative $750. But if you sell it, that will be money coming back in, money added to your account. So we would add $900. Emily then bought it again. She must have seen some more value there that wasn't there. So she spent money leaving her account, being subtracted from her account, at the tune of $1,150, but then sold it again, so money coming back into her account for $1,500. And if you total all this stuff up, it would be a positive $500. And it's important to know what sign you have, because positive means you would gain, and if it were negative, that means you would lose. And that concludes the lesson for 2C. Good luck.